So last video we found the true shape of a surface by projecting a true length line to a point and then projecting that point to the true surface. And we also mentioned that this true shape of this surface is adjacent to a profile view because, and I know this is a profile view, this line right here is the edge of the plane, seeing the plane as an edge, and that's adjacent to a horizontal plane. So this must be a profile plane, which in turn makes the adjacent to it being a horizontal plane. So I can find direction on here, which would be called strike, but I'm more interested in maybe slope or something, and so I would have projected from maybe my front view first to get the secondary auxiliary view, basically. Okay, so I want to extend this to one other step, so let's go back to model space and set my filter to vertex, and let's say this Z point drops down to maybe close to half. And here's the original bars there, but that's okay, or the wireframe. That won't show up in the layout views. So now the point XZ is no longer true length in the top view because it's not parallel to the reference line between the views. So this causes another auxiliary view to be produced before I can show the true length or true shape of that surface. So I'll use a different layout view for this. Let's delete that and add again the front and the top views here. And now I want to still find the true shape of surface B here, which is under my cursor. So instead of treating this as a true length line, which it is not now, I need to project horizontally or parallel to it. So one way to do that is just in phantom view, just draw a line. There. Well, that line's parallel, isn't it? So let's just lengthen that out a bit. Okay, so if I produce an auxiliary view projected along this reference line, then I should get a true length of this line now. So I'm going to use the projection method rather than do it manually, although well, you could. So let's just use the full section view using that reference line and just place the view here. Might have to, and I'll also add the visible and hidden lines contrary to most section views. Let's take that out. Drop that down a little bit. Okay, so I can see that this now I have a true length line from X to point X to point Z. Now that line is in true length, and so all I need to do is project with a line of sight parallel to that. So again, a perpendicular line to that edge would put this line XZ in a point form, and then I can get the edge of edge view of this plane. So let's just do that real quick. An easy way to do that is just zoom in here and draw a line. Make sure it's perpendicular. There's perpendicular. And then just move that guy out there and lengthen it. So I'm going to project it out here. Keep it sort of close. Okay, now again, just to be quick about this, full section view in this direction gives me a point view of this line, and that point will be here. If you're not sure, if you kind of lose it, because it's not completely easy to see, I can project this perpendicular to that line and lengthen that out, and that should go through the point. So it only intersects right there. So this is the this corner right here is where X and Z are coincident. And then the line, one more line for point W, and then perpendicular to my section view. And I can see that it is not there, but it is this point here. So the line between those 2 points, this line right here, is now the edge view of the plane XZW. And from there, I can project parallel to it, and well, let's go ahead and do that. Another phantom line. So here's the edge view of the plane. Let me snap to the corner. There we go. Move this back out. It's going to be a little messy. Let me extend this. Now, if I had put this on if I projected it on the right where there's more room, this surface is furthest back from this reference line, and it would be all in hidden lines because I would have all these other corners and surfaces interfering. But actually, let's just go ahead and do that. So again, a nice full section to look at that view. Almost fits. Let's go visible and hidden. And there is the hidden, the surface X, Z, W, all in hidden lines. Now they would be object lines if I projected it the other way, of course. And there's the true shape of it in any case.